So let's discuss the exercise number 2, and we need to find the derivatives of the functions. So here are the formulas that we will use, so make sure you know them. So let's start with the first function. So e in the power of minus x squared divided by 2 multiplied by arctangent of 2x, and we need to find the derivative of this function. So take a look at the 11th formula. Here we have the derivative of two functions, and in this case we need to present them as a sum, where the first component is the derivative of the first function multiplied by the second function, and the second component is the derivative of the second function multiplied by the first function. So here we need to do exactly the same. So firstly, we take the derivative of the first component, so it's e in the power of minus x squared divided by 2, and multiply it by the second component, and then we add our first function without the derivative and the derivative of the second component. In our case, it is arctangent of 2x. So the derivative of the function, this one, will be equal to minus x squared divided by 2 derivative and multiplied by e in the power of minus x squared divided by 2. So firstly we take what is in the brackets, and then we multiply by the derivative of the power, because there is x there, and then multiply by arctangent of 2x. So now we will write the exponent, and let's look at the formula of the derivative of arctangent. It is the 10th one. So we need to take the argument and put it into the denominator in the second power. So in our case we have not simple x but 2x. That is why firstly we need to multiply by the derivative of this inner function, and then we will take the argument of this function and put it here in the second power. So now let's simplify what we have here. So if we take the derivative of the function minus x squared divided by 2, we will get minus 2x divided by 2. Then we will multiply it by e in the power of x squared divided by 2 and by arctangent of 2x. Here the derivative of 2x will be just 2, because 2 is a constant. And this fraction will look like this, 4x squared. And if we want to just simplify it even more, if we look that carefully, we have here exponent and here exponent, and we can take it out of the brackets. So in this case, we will have 2 divided by 1 plus 4x squared minus x, because we divided 2 by 2 and get 1, and multiplied by arctangent of 2x. Speaking about the part b, here our function is a little bit more complex, but still we will need to apply the same rule about the function a and b, and here the function a will be this one and the function b will be this one. So firstly we take the derivative of the function a, so just rewrite it and take the derivative. Then we need to multiply it by the function b, and then we take just the function a, and multiply it by the derivative of the function b. So now let's look at the function, this one, and we see that our natural logarithm is the inner part of our function, so it's not a function into in the other function. So this means that the argument of external function cosine is not simple, so this means we will need to multiply by the derivative of this inner function first. So this is very important, and then we will use the rule about the derivative of the cosine. It's written here. It says that the derivative of the cosine is minus sine x. So this means that we take the argument of our function cosine and make it minus sine in this argument. So in our case, the argument is our function with natural logarithm. So we will write minus sine, and our argument will be inside this function. So yes, and multiplied by tangent of x. So then we will rewrite our expression, and speaking about the derivative of the function tangent of x, it says that is 1 divided by cosine squared x. And in our case, the argument is simple, it is just x. That is why we don't need to multiply by the derivative, because if we do, we'll just get 1. So no need to do this. And we write it like 1 divided by cosine squared and x. So after simplifying, we will get, firstly, we will need to find the derivative of this function, natural logarithm. So it says that we need to take the argument of this function and take 1 divided by this argument. So in our case, again, our argument is not simple. It is 1 minus x. That is why we will need to multiply by this derivative first. So 1 minus x derivative. And then look again. 1 divided by x. So 1 divided by 1 minus x. So then we will need to multiply by minus sign this function by tangent. Oh, there should be one more bracket. And cosine, natural logarithm, and 1 divided by cosine squared x. So this derivative will be equal to minus 1. So that's why we'll just need to put minus before this expression. And that's it. So let's talk about the third exercise. Here we have to find the indefinite integrals. And we will use here the method of substitution. So speaking about the part A, if you look carefully at the equation which we get here, you can see that in the numerator we have function sine, and inside we have a function tangent of x, and in the denominator we have cosine x squared. So if you remember, the derivative of the function tangent of x is equal to 1 divided by cosine squared x. And this means that if we use the method integration by substitution, we can take our tangent function as a u, and the derivative of the u function will be 1 divided by cosine x squared. And now we just need to rewrite our integral. So it will be integral sine, and instead of tangent we will use u of x, and And as we have here 1 divided by cosine x squared, and it is the derivative of the u function. And yes. And if you can notice, our expression is very similar to this one. So we have u and derivative of the u function. So now we can just write sine u du. And after substituting like again, we will substitute u by our tangent function. So sine tangent of x dx, because we have x as an argument, and we will get here minus cosine tangent of x plus our constant c. And that is because we used the first formula that sine x dx integral is equal to minus cosine x plus c, and just instead of x we used our argument, which was tangent of x. So speaking about the part B, we will use here method called integration by parts, and here we have an integral and we need to find functions f and g, so derivative of the function f and g, and in our case we will take e in the power of minus x as a derivative of f function, and the part with x squared plus 1 we will take as a g function. So f derivative is equal to e in the power of minus x, so then the function f by itself will be equal to the integral of this, and it is equal to minus e in the power of minus x. So we took x squared plus 1 as a g function, and the derivative of this function is 2x. And now let's write our integral. So our integral was this one, and now we will need to take f function multiplied by g function, and our f function is here. It is minus e in the power of minus x, and our g function is this one, x squared plus 1, according to our formula. And then we will take the integral of f function, and again this minus e in the power of minus x, and we will need to multiply it by the derivative of the g function, and the derivative of the g function is equal to 2x dx. And here again we will need to apply the method of integration by parts once more. And in this case we can take this part as the derivative of the f function, and our initial function was f is equal to e in the power of minus x, and g function, so it was the derivative and it is the g function, and g function is equal to 2x, and the derivative of the g function is equal to 2. So now we are working only with this part. So and now we will rewrite our equation again. So firstly, according to the formula, we need to take f function multiplied by g function. So in our case, f is equal to e in the power of minus x, and multiplied by the g function. In our case, g is equal to 2x, and subtract the integral, and inside the integral we have f function and the derivative of the g function. So in our case, f function is equal to e in the power of minus x, and the g function, the derivative of g function is equal to just 2. So now we will rewrite it, and we can find the integral of this part. It is minus 2 multiplied by minus e in the power of minus x plus constant. So we take 2 out of the integral. So it is only the part of our answer. So I will rewrite it to make it even more simplified. So it was only the part of the answer because we were talking about only the right part of the expression. So now let's rewrite it again. So we have our integral x squared plus 1 e in the power of minus x dx, and it was equal to minus e in the power of minus x squared plus 1, and we need to subtract the part which is in these blue borders, and it was equal to this case. So minus e minus x multiplied by 2x plus 2e in the power of minus x, and I'll add the constant in the end because it doesn't matter is it with plus or minus. And we can take this thing out of the brackets. So it will be minus e in the power of minus x multiplied by x squared plus 1 plus 2x plus 2 plus c. Oh, don't forget that you have also here this component, and in the end we will get minus e in the power of minus x multiplied by x squared plus 2x plus 3. So now I will comment on the exercise number 4. Here we need to find the area of the region bounded by the curves. So if we draw a graph, we will see that y is equal to 1 minus x squared, it's a parabola, and y is equal to minus 1, it is just a line. And according to the task, we need to find the area, this pink shaded area. So first of all, let's find points of intersection of these two curves. So for this, we will need to equalize our two functions. So minus 1 is equal to 1 minus x squared. X squared is equal to 2, and x is equal to plus minus square root from 2, and it is our boundaries of the integral that we will take now. So integral from minus square root from 2 to square root from 2, and here we will need to write an expression containing our two functions. But first of all, let's see which function is lower than another. On the graph you can see that the line is located lower than the parabola in this particular place where we need to find the area. So this means that firstly we will write our function which is higher on the graph, and it is our parabola, and then we will subtract the function which is lower, and it is the line in our case, and we will subtract minus 1. So after this, we will just need to simplify the integral. 2 minus x squared. So to simplify it, we need to take the integral from our function, and we will receive 2x minus x in the third power divided by 3, because if we take the derivative from this one, we will get exactly this equation. So, and on the right, we will put our numbers, the boundaries of our integral. And after that, it is very simple. You just take the boundary of the integral and put it into the expression. So firstly, we will take this boundary and put it instead of x. And then we will subtract the expression which we will get if we put this boundary. So 2 multiplied by minus square root from 2 plus minus square root from 2 in the third power divided by 3, and so now we'll just need to simplify it. So we get 4 square roots from 2, because we take this and this, and minus 2 divided by 3 multiplied by the square root from 2 in the third power. So we receive 4 square root from 2 minus 4 divided by 3 multiplied by square root of 2, and finally a divided by 3 multiplied by square root of 2, and that is the answer. And now the final task, how to prove by definition the derivative. So firstly, we need to take the limit of the function using the definition of the derivative. So here I'll write our function with the new argument with x plus h. So instead of x, I'll use x plus h, and I'll subtract our function which was with the argument x and divided by x. So that's the definition of the derivative. And now I'll need to compute this limit to see what will be the value. So I simplify the equation by opening the brackets And now we can see that we can take this part out of the brackets because it will simplify our equation. So limit in the power of x squared plus 1. So here we are left with 2xh plus h squared, and here just 1, and divided by h. So if you remember the formula, it was when we were considering limits, there was a formula according to that this whole expression will be where h is close to 0, it will be equivalent to just this one, this power. So now we will rewrite the limit again. So e in the power of x squared plus 1. Here we will use the equivalent function, which is 2x multiplied by h plus h squared divided by h. So now you can see that we can take h out of the brackets. So here we will have just h. And now we can, oh sorry, I forgot about the limit. We will need to write it here. And now we can divide both by h. So and now our limit will look like this. So we know that h is close to 0, and so that is why our limit will be equal to e in the power of x squared plus 1. Here we will just write 2x, and that proves that this part is equal to this one. So we have proved that the derivative of this function is indeed equal to this one, and that is the answer.